Sometimes the most elegant solution to a really complex problem is just hiding in plain sight. Today, we're going to dive into a research paper from IBM that is a perfect example of this. It's called A Surprisingly Simple Approach to Generalized Few-Shot Semantic Segmentation. And honestly, that surprisingly simple part is exactly what makes it so genius.
So let's start with the big multi-million-dollar question. Imagine you've got an AI, and you show it a single picture of a new kind of chair it has never ever seen before. How do you teach it to recognize that specific chair in any photo without it totally forgetting what a table or a car or even a dog looks like? This is a massive fundamental challenge for AI.
All right, to really get why this new solution is so brilliant, we first have to understand how an AI sees the world. It's not like us at all. For a machine, the world isn't really made of objects. It's just a giant grid of pixels.
The key bit of tech here is something called semantic segmentation. The best way to think about it, honestly, is like a super advanced digital coloring by numbers book. The AI looks at an image and assigns a category, a color, if you will, to every single pixel. This pixel, that's road. This one over here is sky. And that whole group of pixels, that's a person.
And this isn't just some abstract thing happening in a lab. This is the foundational technology for self-driving cars that have to know the difference between the road and the sidewalk, or for medical AI that needs to find a tumor, pixel by tiny pixel, inside an MRI scan. It's incredibly important stuff.
So, the AI is great at seeing and labeling the world it already knows. But what happens when we throw something new into the mix? This is where we get to the real heart of the problem.
See, in AI research, there's a huge difference between just learning a new thing, which is called few-shot segmentation, and learning that new thing while also remembering all the old stuff. That's called Generalized Few-Shot Segmentation, or GFSS. And that generalized part, well, that's what makes an AI actually useful in the real world.
The reason this is so ridiculously hard is because of a problem called, and I love this name, catastrophic forgetting. It's this classic AI nightmare where training a neural network on something new can cause it to completely overwrite or forget what it learned before. You teach it to recognize a couch, and poof, it might completely forget what a bed is.
So, for years, researchers have been building these unbelievably complex systems to try and solve this. They've been throwing everything but the kitchen sink at the problem.
Just look at this. It's like a Rube Goldberg machine. Previous methods needed all these custom-built parts, really complicated math, and hours upon hours of this thing called meta-learning. Some even used a technique that meant the AI basically had to relearn its job for every single new image it saw. It was just incredibly slow and totally impractical.
But what if there was a better, much simpler way? This is where this new research just walks in and changes the game, with an idea that is so elegant and so effective, you'll kind of wonder why nobody thought of it before. It's called base class mining, or BCM. The paper itself puts the idea beautifully. Instead of building some brand new, complex system, the researchers decided to just intelligently use the knowledge the AI already has. The whole key was figuring out which of the old, base classes the AI tends to get confused with when it sees a new object.
So here's how it works. It's a two-step process. First, you show the AI a new object, let's say a couch. The AI has never seen a couch, so it makes its best guess and says, that kind of looks like a bed. Now, instead of telling the AI it's wrong, BCM just says, aha, interesting. It makes a note that the AI confuses a couch with a bed. It does this for all the new stuff, creating this little confusion map.
Then comes the really clever part. When the AI is out in the world doing its job, it looks at an image. If it sees a car or a tree or a dog, things it's confident about, it just operates as normal. But if it thinks it sees a bed, one of those items from its confusion map, it pauses. It basically says, hang on, and calls in this tiny specialist model. And that specialist's only job is to decide, is this really a bed or is it one of those new couch things? It's just a simple, super efficient division of labor.
Okay, so the theory is beautiful, right? It's simple, it's logical, but does it actually work? Does it beat those older, way more complicated methods? Let's take a look at the data. The answer is a huge, resounding yes. Look at this. It's a direct comparison on a standard industry benchmark. The previous state-of-the-art method, a model called DM, scored a 35.1. The new, simple BCM method, it scores a 41.2. That is not a small improvement, that is a massive leap forward.
To be precise, that's a 6.1% jump in performance. Now, in the world of machine learning, getting an improvement this big from such a simple change in approach,
That is a really big deal. And don't forget, this is one-shot learning. The AI did this after seeing just a single example of the new object. Incredible.
And what about that catastrophic forgetting problem? Well, this is the knockout punch. Because BCM doesn't have to retrain the whole model, it perfectly maintains its performance on the vast majority of things it already knew. In their tests, that was over 93% of them. The AI's existing knowledge stays almost completely intact. The simple idea just works.
So let's zoom out for a second. What's the big takeaway from all this? Why does this one paper matter so much?
Here's the bottom line. The BCM method isn't just more accurate, it's better in basically every practical way. It's simple to implement, no custom parts needed, it trains in minutes, not hours, it elegantly sidesteps the whole catastrophic forgetting problem, and maybe best of all, because it's just a clever rule on top of an existing model, it's future-proof. You can easily apply this to the enormous foundation models that are being built today.
And that really just leaves us with one final thought. This research is such a powerful reminder that sometimes the biggest breakthroughs don't come from adding more complexity, but from looking at a problem in a new and much simpler way. It really makes you wonder, what other incredibly complex problems out there are just waiting for their own surprisingly simple solution?